Okay, let's look at the dreaded how many broadcast domains question. This is a typical question that you'll see in networking tests. Networking tests, networking certification exams, things like that. They're going to ask you how many broadcast domains. Well, you look at the diagram and you go, uh-oh. And a lot of people have a hard time with this question. So we'll break it down and we'll start with a simpler example and we'll show you that actually answering a question like that's pretty easy. All right, so we'll look at this one, we'll look at this one, and maybe we should even start with just this one. Okay, so we'll start here. First of all, when they ask you how many broadcast domains, what they're really asking you is how many networks. A broadcast domain is a network. All right, broadcasts are sent throughout a network. They don't pass through the network to other networks. In other words, broadcasts stay behind the network or stay behind the firewall or are bound by the router. So a router is what contains broadcast domains. If you look at this example right here, you've got a switch. This is the symbol for a switch and a switch, right? And you've got all these computers, right? And you have, let's say, these servers here. And let's say the scenario actually looked a little bit more like this, right? Let's say it looked more like this and we were talking about hubs instead of switches, right? And you know, in a scenario like this with hubs, if you have broadcasts, you could end up with a broadcast storm, which is broadcasts going just everywhere. And even in such a scenario like this, even with the switches, broadcasts, you could have a broadcast storm. So too many broadcasts on the network would decrease performance. And so then the question they always say is, well, how would you improve performance on this network? Well, first of all, if you had hubs right here, right, one way to improve the network would be to change the hubs into switches, right? And then the other way to improve the network and actually would be to take this single broadcast domain, right? One broadcast domain. There's no routers. It's one network. They're all, let's say, on the 192.168.1 network. One way to improve it would be to bring out a router and turn it into two separate networks or two broadcast domains. Now, these broadcasts generated by these clients will stay on this network over here, and then the broadcast by these servers will stay on this network over here. So now instead of one broadcast domain, you have two broadcast domains. Now on the tests, they'll confuse you with that because they'll say routers break up broadcast domains. Well, what does that mean? Routers break up broadcast domains. Well, quite simply, what it means is routers create broadcast domains. If you have a router, you now have two networks and you have two broadcast domains. All right, so how many broadcast domains in this example? Two. How many now? One. All right, so we go to the next network, right? Another problem that we'll see is people will say, well, you know, if this last example there was two networks, right, and the router has two interfaces, so the number of broadcast domains equals the number of interfaces on the router. And yes, each interface on the router signifies a network, but it doesn't always work out. In other words, if you have this scenario, this router has two interfaces, Ethernet, serial, right? And you have a scenario where this is a broadcast domain, right? That LAN, okay? This interface, this switch, this computer, they're all in the same network. That's a broadcast domain. And you have this scenario over here, right? And that's a broadcast domain. This router interface, this switch, this server, right? This is a network, right? But you can't simply count the interfaces because this router is connected to another router, and in between the two routers is a third network, right? If you simply count how many interfaces on the routers, 1, 2, 3, 4, you'll come up with 4 networks, but that's not correct. In this case, there's only 3 networks. One in between the two routers, and one over here. And what does that mean? It means that these routers, they're on the same network. They need to be in the same network address space, right? If this is 10.0.0.1, this needs to be 10.0.0.2. Okay, so now we can go over and look at this example and we can answer it a lot easier and we can get the correct answer. So we just count the networks. All right, this router has an interface right here connected to a switch, connected to a client. We'll draw a circle and we'll say that's one network, one broadcast domain. And then we say this router has an interface right here connected to a switch. I don't see any clients, but still that is, let's say, a network. In between the two routers, we've got a network, right? Okay, now we've got three networks. Now, what about over here? Well, this router is connected to a hub, which is connected to a server, and that is a network. So there's a fourth broadcast domain or fourth network. And now we look at the hard part of the diagram. This router is connected to a switch, but this switch is connected to another router, and this switch is connected to another router. Well, that means that all the devices connected to this switch are on a LAN. In other words, they all need the same address space. So this is one broadcast domain right in here. That's one network. These routers would all need the same network address space. They'd all need to be on the 192.168.1 network, for instance, right, or something like that. So that's one broadcast domain. And now coming off of this router, we have a hub and a printer, right? And that's another broadcast domain. And then coming off directly connected to this router's Ethernet interface is a server. Server directly connected to the Ethernet is a crossover cable. And we'll say that is a broadcast domain. So in this diagram, there is 1, 2, 3, 4, 5, 6, 7 broadcast domains, or 7 networks. All right, I hope this example helps you out a lot on your tests and your certification trials.